Module 3, we're going to discuss best practices. When we're talking about best practices in data management, a common phrase that you might hear would be trash in, trash out. So your data is only as good as how it was collected and how it was stored. And there's nothing that can be done for poorly collected data or poorly managed data. And so for this reason, the principles of good documentation practices are universal to all data. In this module, we're going to cover those best practices and how data collection and storage works. The first thing is that you need to do is you really have to outline your aims. You need to define what data you plan to collect and how you plan to collect it so that you achieve what your project's aims are. By incorporating the additional data that have nothing to do with the protocol's endpoints, it introduces the risk during your endpoint analysis, and it also exhausts your project management resources. So as my number one tip that I tell people to do is when you're creating your outlines of your aims, create the tables and the figures, the template that you plan in your future publications, your grant submissions, or any protocol execution or management timelines that you're going to need. By having those blank templates available on the front end, you know what data needs to be collected later on. Another best practice that really needs to be taken into consideration is to focus on the data quality. So data standards ensure that you have the ability for the data to be valuable. A real life data is very dirty. It's inconsistent, it's duplicated, it's inaccurate, and it's out of date. And so all these data defects contribute towards data variability, which lowers your statistical power. In order to counteract this real life challenge, you need to consider what your data quality criteria are. I've listed here a few that I consider to be good data quality criteria. The first one would be consistency. So ensure that your data comes from a collected sources that are synchronized and they reflect the same information consistent. Another one would be validity. Indicate whether your data meets the standards or the criteria defined by the data management team. A third one would be integrity. Indicate whether your data is collected is sufficient in order to draw the conclusions you need for your aims. And the fourth one would be accuracy. That the data that's collected represents exactly what it is supposed to be. Outdated or incorrect data can negatively affect your outcomes. So data consistently refers to the validity of the data source in which it's stored, and the data integrity attributes towards the accuracy of the data that's stored within the data source. And traditional source model is a good example that demonstrates how a process can introduce risks towards your data consistency and your integrity. To elaborate, from a data integrity standpoint, a coordinator may misinterpret or incorrectly record medical measurements on paper CRF. Without an automated validation, a coordinator will not know they made an error until they input the data into the EDC. From a consistency perspective, paper source introduces all kinds of risks. If the coordinator, for example, loses the paper source, there's no validity towards the data in the EDC. The paper source can be modified without validated tracking systems. In other words, you could erase or reword the measurements and reproducing a paper CRF from memory. Electronic source is known to significantly improve both the data consistency and the integrity. So focus on your data quality. Another best practice to take into consideration is how you build strong filing name and cataloging conventions. So your nomenclature, which is a system of names or things, and your classification, which is the organization of things within the categories, are important concepts to consider when dealing with the development of your data components, also called your variables. Creating a data naming standard will simplify your life. Oftentimes, databases have many variables, and you want to be able to identify each component at a glance. Creating some type of naming convention will increase your database's reliability, readability, and provide a lifetime information about the data component. Databases will live for a very long time, so you need to develop a scheme that people will be able to see later on. Similarly, the structure changes at the database level should be avoided and only done when necessary. If you make a change to a variable name, the associated data that could be orphaned or it could be lost. If you make a change to the code and the associated label, all the existing data will be recoded to that new structure, and this could result in misidentification or loss of data. Additionally, the individual that develops the database is usually not in a vacuum. So the database structure is often shared with other data managers and statisticians. Having a common naming convention rule allows each individual working with the objects to understand their meaning with minimal additional information. In fact, its common nomenclature can allow statisticians to reuse common programming for analysis, and it can allow developers to connect databases easily. A clinical trial commonly uses something called a CDISC standards to create clarity across clinical research platforms through a standard for formats, methodologies, and data frameworks. Using CDISC naming standards is considered the gold standard for naming conventions. However, sometimes it's easier and faster in the beginning to create your own nomenclature. If you decide to create your own, write down the naming convention and a data management plan that explains your naming convention. Things to consider when naming objects include: use lower letters when naming database objects. Use underscores to separate words. Use singular for object names. For example, user, role, not plural, users, roles. Keep object names short but descriptive, less than 26 characters. For example, participant underscore name, father underscore name, mother underscore name. Dates describe the date, what the date represents. So you could use names like start underscore date or end underscore date. They're pretty descriptive. If you want, you can describe them even more precise by using names like medicine underscore start underscore date or medicine underscore end underscore date. Actions help build automation by creating objects that include the action. So use trigger underscore email to create a single leverage point for the automation to read. You can also include versions in when it's applicable in your variable. So you could have consent underscore v1 for version 1 of your consent. Apply these best practices from the start and continue using them when you add new objects, and you'll keep your database structure very well organized and easily readable. Another thing to consider when you're taking into consideration best practices is to reduce duplicate data. Clinical trial data can be received from multiple sources. It's collected at various time points or by different people, and all these various data points can easily result in chaotic data collection, leading to duplication of the unique data points. There are a few factors that can contribute to data duplication, such as a variety of coding standards that mean the same thing but are misused. For example, if you have a yes-no variable where yes equals 1 and no equals 0 in one option, and in another source, yes equals 1 and no equals 2 in another option, the numbers and the codes don't match. Someone has to go back and recode everything in order to make things match. Another factor that contributes to data duplication would be poorly categorized metadata, such as a code book or a data dictionary that explains each variable's names, labels, codes, code labels, validations, etc. Having a reliance on the exact matching of textual values and codes can cause duplication, and also duplication of unique data fields collected in the electronic source records. Identifying unique data fields that may be collected many times is very important to remove the burden on the individual entering the data and the individual analyzing the data. Here are some methods that can help you reduce data duplication. The first one is called normalization and enrichment. Improving and standardizing your data expected to be recorded at the source is what this is. Provide any additional metadata that is helpful in the analytics and the data usability, but is not expected to come from the source. So for example, if you collect clinical lab results, then add a field for the reference range. If you are developing a nomenclature that goes across your studies, for example, CDISC is recommended for the FDA studies, put that in your metadata. If you utilize REDCap piping to remind data entry individuals of a subject idea instead of capturing the field again. Another thing that you can do is you can have organization. By organizing your available data and data logically by topic while maintaining the source data. So that's one thing you can do. For example, medication can be logically grouped while leaving the source data intact. You can also do deduplication, which is where you eliminate duplicate entries of the same information. For example, not listing a subject's ID on every instrument. Instead, using either the normalized or the original form. Another thing to take into consideration, and we've kind of mentioned it already, when you're talking about best practice, is metadata for your data sets. So the metadata is descriptive information about your data that you're using. It should contain information about the data's content, the structure, the permissions, so that it's discoverable for future use. If you don't have this specific information that is searchable and allows for discoverability, you cannot depend on being able to use your data in the future. Metadata includes the who, what, when, where, why, and how the data set was generated. In general, there are two types of documentation that help ensure usability far into the future. You need descriptive or study level documentation and structural or data level metadata. Similar to naming conventions, there are metadata standards too. Documentation needs will vary from projects, so at the minimum, you should have the following. You want to catalog items such as the title, the data author, the identifier, the what the data what data this set contains, the funder, the rights of the intellectual property or the licensing rights for the data, access information, project descriptions, methodology on how the data was collected, data structure, which includes the relationship between the items, variable names and other data level documentation, your data citation, which is where your preferred format for citing the data, software that's used, including the version of the software so the future users that are using a different version can work through the differences in the software issues that might occur. And lastly, context is essential. You have to give context to the project for why it was created, if the hypothesis were trying to be proved or disproved. This information will then lead you to create and understand the data lineage of how the data flows to track it from its origins to its destination. And this is very helpful when mapping relevant data and documenting data relationships. Metadata that forms a secure data lineage is the first step to building a robust data governance process. So when you're prioritizing how your data is going to be collected, you have to prioritize the security. Both in the United States and in Europe, you have to take steps to make clinical trial data more transparent in order to enhance the research and increase the patient safety. But at the same time, there's all kinds of new regulations that are being implemented to protect the personal data of the citizens. So the FDA is establishing guidelines for transparency through the use of de-identification and mass data. And the hurdle is protecting data privacy of the patients while protecting the study's data. The European Union just recently approved the clinical trial regulation of 536, and it's creating a EU portal for publishing data once a marketing authorization application is submitted. With this portal, investigators must consider how they are going to remove their patient identifiers and make the data acceptable to be compliant. Meanwhile, the European Union has also recently taken a data protection to a new level. And as of May of 2018, the EU passed the General Data Protection Regulation to protect citizens' data and information. Of course, health data falls into this category. Clinical trial data is considered sensitive personal data, and therefore GDPR requires tighter conditions for processing the data. In terms of a clinical trial, investigators must look at the process in which they carry out patient consent, but also carry out a data protection impact assessment. And it's the responsibility of the investigators, the sponsors, the vendors for the compliance when it comes to the handling of the data. There are a few things that you can do to help. One is data autonomization. It's a type of information sanitation where the intent is for privacy protection. All data sets should have the same standard. This goes back to the CDISC compliancy that we were talking about in the last section. Next is to have a workflow and a quality control check process in place so that you can de-identify and autonomize the data. De-identification involves removing or recoding of health information that could identify an individual, such as patient identifiers, free text verbatim terms, or references to dates. Subsequently, data autonomization involves destroying all links between the de-identified dataset and the original dataset. A typical data autonomization workflow includes some type of CDTM, ADAM input, a metadata or a functional specification, a data autonomization macro, an anonymized CDTM, ADAM data, anonymized procedure data. There are 3 levels of patient data that need to be taken into consideration. Your level 1 is your direct identifiers, such as your biometrics information. Your level 2 would be indirect identifiers, such as the date of birth or body measurements. And your level 3 would be your risk of data linking by combining more than one data point. All human subject research has to take into consideration these data anonymization, whether you're using public health data or whether you're using patient level data. Another thing that needs to be taken into consideration is the system's security. I'm not going to cover this one. It is just something that you need to know is something that needs to be taken into consideration. And the next thing that also needs to be considered is the software security. So the system security would be where the software is sitting, and that would be the infrastructure of what it sits on, the servers and the people that are maintaining the servers and things like that. The software security is your verification and your validation that process that is checking that the software system meets the specifications the vendor said it could do and that it fulfills its intended purpose. So verification of processes are completed by the developer. However, a software validation has to be performed in the environment the software is being used. A software validation is the process of establishing a documented evidence that confirms the computer system has been installed correctly, it meets the user's needs, and the functions according to how it's intended to be used. The FDA software validation is when an FDA regulatory company demonstrates and documents that their software can accurately and consistently result from to meet predetermined guidelines for compliance and data quality management. While the FDA offers recommendations, they don't tell institutions specifically how to validate their software, nor do they define the results and what that should look like. Instead, it's up to each institution to explain how they intend to validate their software and to provide evidence that it's been done and that it works the way it's intended to. So the only rules for FDA software validation are that the products you make and the processes you follow have to meet the FDA standards for production and inventory management, and that every step of the validation process has to be documented. Validating REDCap requires you to have an FDA 21 CFR Part 11 compliance. And so, in general, all REDCap instances across the world have to have a hardware administration installation qualification, a software administration perform the operation qualification, and a study team is responsible for performing the production qualification. If you want more information on validation of REDCap, there is a link on how we validated REDCap at our institution. The important piece to this is if you do end up building anything that's ever going to be require the FDA's 21 CFR Part 11 compliance, it will be your responsibility to do the production qualification. And by the time you get to a point that you're doing this, it's you're gonna want to talk directly with the admin team to get more information on what your needs are going to be. But in a production qualification in general, this is your plan document that step by steps of what's required within your REDCap database and how to put it into production. And it's a general document, and it's very specific to how your database runs, or how your project runs. Its intended purpose is to document how the databases are going to be entered into REDCap, how the data gets there, and that it functions the way it's supposed to. There are additional resources for more best practices if you want more information. At this point, we are done with Module 3.